All right, here we are again. Let's move on to actually accessing a database using PHP. It's number 6. All right, let's look at the basic connection algorithm. I got 3 asterisks. Please memorize this. Connect to the database. That's going to be our very first step. We're going to learn how to do this, but that's the key first step. We then need to be able to handle connection errors. Maybe we've got the database name wrong. Maybe the database management system is down. Maybe there's all sorts of things that could go wrong. We've got to be able to handle that. We're going to construct and then execute some kind of an SQL query. Initially, these are going to be select queries, but they could be update or insert queries. It's up to you. Then you need to process the results of the query. Quite often, when we're selecting data, this is going to mean generating some markup, generally as well in a loop. So processing the results. And when we're all said and done, we need to free resources and then close our connection. Okay, so remember the 3 asterisks. Remember, you need to learn these 5 steps. So this is basically what it looks like, these 5 steps. This is a diagram from the book. Here you can see we're making our connection. Looks like there's some information here about the database, where it is, the user, the password. You'll notice the try catch. So PDO is kind of an object-oriented approach. So try catch blocks, which you've seen in JavaScript and earlier in your life, programming life in Java. Try catch blocks are the object-oriented approach for managing errors. Step 3, construct your SQL and then run the SQL. Step 4, do something, process the results. So again, typically it's some kind of a loop. And then finally, when you're all done, closing the connection. So let's take a look at each of these in more detail in turn. So, connecting to a MySQL database using the PDO object-oriented approach. So in that previous slide, you saw something where there was a connection string, there was a username and a password. Here I've just hard-coded it, all of this information for now. That information is passed to the constructor of the PDO object. Then there's this bizarre set attribute. This set attribute line is totally optional, like we don't actually need it. It just tells PDO to give us some helpful error messages if something goes wrong. And when are things most likely to go wrong? Well, certainly when you're first learning how to work with PDO is probably when you're going to need the error messages the most. So I find I don't really remember this. I usually just copy and paste this line. I'm sure you can get by doing the same kind of copying and pasting. All right. Well, how about connecting to a SQLite database? Well, we can use PDO as well. In this case, you'll notice the connection string is a lot more concise. It indicates the type of driver that we're using and really where that file is. There's no username or passwords with SQLite generally, and so it's actually simpler, but you'll notice it's still PDO. This path, by the way, is relative to the script location. So this is assuming here that this file, movies brief DB, is in the same folder as whatever PHP page is running this file. Because you typically will have multiple PHP pages that need database access, it's pretty common to localize your connection information into constants using the define keyword and place those into a file and then include the file where the database access is needed. So for instance, in the labs you'll see that there's this file called config.inc.php. We define a bunch of constants and then a connection string is just created out of those constants. By the way, this char set UTF-8, That's just to make sure that the PDO gives us is able to deal with UTF encoded data. Sometimes like accents and other European accents and things like that. If we want to make sure that those get handled correctly, we can add this to our connection string. At any rate, now we can have multiple pages, right? Page 1 and page 2, they can just, they can maybe make their connection, but they just include the config file, and it's just existing in one location. So then, if the username changes at some point in the future, we just have to change it in this one location, and all of our pages will work. Speaking of connection strings, what are they exactly? Well, most database APIs, as it says here, make use of these connection strings. They're strings. They have information about how to connect to a database. Different APIs and different database management systems have their own syntax and format. So for instance, when you're using MySQL or MariaDB and XAMPP, the connection string looks like this. This indicates what driver to use in MySQL. Where is it? Well, we're running it off of localhost. And what's the name of the database? It's movies. Well, on my own personal website, I've got MySQL. So the host name is the same. The driver name is the same. But the host name is totally different. It's not on my computer. It's just MySQL's running on some computer somewhere out there in the internet. So there's some kind of URL for it. Likewise, the database name, is probably going to be more complicated and so on, but still, it's more or less the same. As we saw from this a couple of slides ago, SQL Lite has a simpler connection string. In my Web3 course, I make use of MongoDB, a NoSQL database. It also has connection strings, but it's got a slightly different format, but it's kind of similar. You can see it has something that sort of indicates what kind of driver to use, and then a URL or something to indicate how we can get at it. I have MongoDB on a hosted environment called Mongo Atlas as well, and there it's more complicated. Usernames and passwords have to be provided and so on. So connection strings are kind of universal, though the syntax for a connection string is unique to each database management system, so you have to typically look through the documentations and so on to see what you need. All right, let's go back to this again, this algorithm that we've been looking at, right? We've been talking about number 1 here. Let's take a look at number 2, handling the connection errors. Well, as we saw, any of our PDO code should be within a try block. If something goes wrong, maybe we have our SQL misformed, maybe the database is down, what have you, it'll come to this catch, and then we can decide what we want to do with it. Maybe we want to redirect to some kind of an error handling page. Maybe we just want to display a message, or maybe we just want to stop the PHP process. That's what the die command does. Accessing the MySQL and PHP, the real heart is number 3, executing the query. So we typically are going to have some kind of a string, which is going to consist of the SQL that we want. And then we're going to make use of a method of the PDO object called query, which, as you can see, takes a single parameter, some sort of an SQL string. By the way, in the examples in the books or in these slides, I often use select star just because it's less typing and writing for the students in the class, and that's fine. But in a real website, you wouldn't use asterisk because asterisk returns all the data, all the fields. And maybe you're not interested in all the fields. Quite often you're only interested in a set number of them. So normally you wouldn't use star, but you'd actually supply a field list. At any rate, what does query return? Well, query returns something called a result set. In fact, it's actually an object called PDO statement. We'll see what this thing does. It's got a lot of different kinds of things it can do. It also will return false if it failed. So this means you can do some, you can have some kind of conditional after it, like if result or something to that effect. Well, I've already used this term result set, but a PDO statement is more, I find it's more comfortable to just refer to it as a result set, a special type of object through which you can iterate to gain access to the data returned from the database sequentially, record by record. That sequentially part's quite important. What this means is that you can't just say, oh, boom, give me this information on record 27. You actually have to loop through all of those records. Well, as you can see, so here's maybe an example. Here again, I'm not using star, but I'm asking for specific fields, ID and name. So I'm going to run the query, and then I've got this result. Well, what can I do with this result? Well, typically you're going to iterate through it, and a classic way to iterate through a result set is with a while loop. In our JavaScript, we sometimes joked about never using while. Here in PHP, we get to use the while. What fetch does is it returns the next record. So, or let's call it a row. So as this loops through, each iteration through, it's going to run another fetch and put the result into row. Unless it can't fetch anything more, i.e. there's no more data, then it just returns false, and this while loop exits, and we continue on that. Inside this while loop, we can now reference the actual returned field data using the key names, and the key names match the field names. So in other words, row appears to be some kind of associative array. So again, let's take a look at another example. Here we've got, so this is our table that's been returned, and our row, you can see it, the keys of our associative array match the column names. So that makes their code quite easy to understand and identify. However, it's not completely true that row is an associative array. We'll come to that in a couple of more slides. I just don't want to complicate things. So, the neat thing is a PDO statement implements something called the iterable, that's a tough word, interface, which means you can also iterate through a result set using a standard for each loop. So as you can see here, we can use for each, and we can access it the same way. So you can see here, right, we used while, and here we use for each. They both do the same thing. Oh, I'd forgotten that I put that here. Yeah, so these are interchangeable. You can use whichever. I find looking online and so on, you tend to see this a lot because this was what you had to do with MySQLi. You had to have some kind of a while loop. So a lot of PHP code, which is and help for PHP code online, is often quite old. So that's why you tend to see this kind of while loop, though the for each is fine as well. Here's where things get a bit more interesting. Each row returned from a fetch or for each returns actually an array in which each field is available as both a key and as an index. So in fact, this right, these both access the same field. This is kind of powerful. It does get you into trouble later when you try to do a JSON export, but we'll talk about that a little bit later. I think my software limits me to 15-minute videos, so I guess I'm going to have to break this section up into yet another video.